Opportunity to present my research. My name is Gavin McNicol. I'm an assistant professor at the University of Illinois, Chicago. Humans have direct control over large portions of the global methane and nitrous oxide budget. That means there's significant opportunities for climate mitigation in managed and coupled human natural systems. Biogeochemical flows associated with sanitation are particularly poorly quantified globally, and their mismanagement underlies a global public health crisis affecting almost half the Earth's population and contributing to over 800,000 deaths annually from preventable illness. In this work, we quantify the climate change dimension of a sustainable development synergy between public and planetary health in the sanitation sector. In Haiti, about 30% of the population lacks access to improved sanitation, and about 10% rely on open defecation, which means they have nowhere to go. And these statistics unfortunately mirror the global sanitation crisis. International research and development enterprises are designing new sanitation systems that work in low resource settings. Innovations broadly reflect recent transformations in the waste sector to value human excreta as a resource rather than as waste. When nutrient and energy recovery and climate regulation become a part of the service value chain, they can make essential reductions to the cost of sanitation. So we worked with Sustainable Organic Integrated Livelihoods, or SOIL, Haiti, an American NGO working in Haiti to provide sanitation services. Their circular design uses a combination of container-based toilets that are easy to use to collect, contain, and transport waste, with offsite thermophilic composting, a treatment method to neutralize pathogens and recover a sellable product. We envision a repaired nutrient cycle in Haiti where the dependency on foreign imports is moderated by upcycling waste into compost. In Haiti, my former advisor had already shown that methane emissions could be lower from composting than other traditional conventional waste storage systems such as pit latrines, but we needed more data. So Becca and I spent a year collecting thousands of soil gas flux measurements over compost piles. And in the end, we became an extension of SOIL's research program. We worked with a lot of agronomy students for this, including one junior Francois, who is a co-author on this poster and the paper that resulted from the work. So our thousands of manual gas flux measurements showed that we could generate scalable emissions factors for the greenhouse gases. And those were equivalent to aerobic wastewater treatment systems, but for much less cost. We found that these emission factors could be scaled, and at a global scale, if we divert waste from pit latrines to composting systems across urban slums, we could mitigate 13 to 44% of wastewater sector methane emissions, so that's about 2 to 6% of global methane emissions.